So over the course of today, you've heard a lot of information about age-related macular degeneration. You've heard about the challenges, and you've also heard about some of the advances that have happened, particularly with regard to wet age AMD. And I imagine that there are at least a few of you in this room who are impatiently waiting to hear about similar advances for dry AMD. These advances are coming. There are already several drugs that are in human clinical trials, and they're coming because research makes advances happen. So in the few moments that I have right now, I just want to tell you about some of the scientists that are supported by the Foundation Fighting Blindness and how they are contributing to the global effort that's going on right now to find additional treatments and cures for AMD. So first of all, our scientists are contributing to the effort to control rapid vision loss that can be associated with wet AMD. So I know you've heard a fair bit about wet AMD today, about those tiny blood vessels that are growing up from underneath the retina, and about the drugs that now can be used to stop the growth of those vessels. So we actually fund several different teams right now who are looking at treatments that might potentially be combined with that sort of therapy. So for instance, we have a team that we fund in Newfoundland at Memorial University, who's looking at the factors that cause blood vessels to leak. So if you could control not only the growth of those blood vessels, but how likely they were to actually leak blood and fluid into the retina, you might potentially, or would hopefully potentially, create a therapy that would be far more effective than what we can provide today, and might provide better reversal of symptoms. So not just stop the drug, but actually reverse the symptoms for more and more people. So that's one direction that we're doing, and we actually have several teams that we fund that are looking at different factors that might contribute to wet AMD. So what about dry AMD? As you know, dry AMD progresses usually more slowly and often over many years. And so for this kind of condition, our scientists have most often focused on therapies that protect nerve cells and light-sensing photoreceptors and help them resist the stresses of the garbage and the toxins that build up in the eye from those drusen, and hopefully would help them survive for a longer period of time to extend a person's useful vision. We actually have at least 5 teams that are working on different sort of nerve and cell protecting therapies, but I know that the cookies are beckoning back there, so let me just tell you about one. Dr. Kathy Sofidis in Ottawa at the Ottawa Hospital Research Institute is developing a therapy called XIAP gene therapy. XIAP is XIAP, which stands for X-linked inhibitor of apoptosis, but that doesn't really matter. But the therapy, we have been funding her work since 2007, when she first showed that this therapy could protect vision cells when an eye had had a retinal detachment. So the idea would be that it would protect the cells long enough for a surgeon or someone else to come in and reattach the blood flow. And she showed that that could successfully be done. So based on this information, she and her team started to look at how this therapy could be applied to other visual diseases, including retinal diseases. And most recently, she's worked with another Canadian scientist named Dr. Joanne Matsubara at UBC, who is a specialist in AMD research. And together, just this spring, actually, they presented at a conference where they showed that XIAP can indeed help protect the light-sensing cells from the toxins that are present in those drusen, in the garbage that builds up in the eye, and that might slow the effect of vision loss on people, and that it actually might be useful at different stages of dry AMD. So, you can envision a situation where actually people might be treated before they even had signs of vision loss, because it would help their cells resist those toxins, and might also be useful as the disease progressed. The truth is, though, that there are some people, probably some people in this room, who have already experienced really serious vision loss. And that's why over a third of the research programs that the Foundation currently supports are focused on therapies with the long-term goal of restoring sight. So again, we fund multiple teams and multiple approaches, but currently one of the most promising ones, and the ones that you've heard about, is the use of stem cells to create new vision cells for transplant. So when I talk about transplants, people think of like lung transplants or liver transplants, where you transplant a whole organ. And they actually did try that early on in the in the history of all of this science, and it just doesn't work. The retina has to make hundreds of thousands of connections to the nerve cells, and a whole retina can't do that. But what they did find is that cells at early stages of development can make such connections. And so in the last 10 years, a major focus of retinal disease research has been to use stem cells to grow what I would call baby photoreceptors, or baby light sensing cells, which then can be placed in the retina and which then can make those connections. And science has shown that baby photoreceptors, which properly should be called retinal progenitor cells, can build connections. But we also have shown that very few of them survive, so maybe 1 in 100 survive. I'm not a very good gardener, but I know that that wouldn't be much of a garden if only one of 100 of your seeds survived. And it's similarly not enough yet to restore sight to people with AMD. And that's why I want to tell you just quickly about a foundation-funded scientist who's recently had a great idea. So his name's Gilbert Bernier, and he's in Montreal. And he's proposed growing tiny sheets of cells in his lab where the baby photoreceptors would actually be connected to another group of cells called the RPE, which are cells that help to nourish and support the vision cells. And so they would be connected together, and then those cells would be implanted as a block into the center of the eye. And that's very much like taking, you put your tomato seeds in a little pot, you put it on the windowsill, you grow it up, and then you plant the thing together in the garden, and it helps it flourish. And this strategy, we hope, will work particularly well for AMD because, as you know, most of the damage is concentrated and squeezed in a tight area together in the center of the macula. And so Dr. Bernier in particular has focused on growing the cells that would be most appropriate to treat people with age-related macular degeneration. He's already been successful in creating those sheets of cells, and he's now at the point where he's testing their survival in laboratory mice. This study is just one example of the imagination and ingenuity of the scientists funded by donations to the Foundation Fighting Blindness. Their work is helping us create a world where treating supposedly incurable conditions will become possible. Thank you.